So we're going to look at simplifying variable expressions. In order to help us, we're going to look at some properties of all real numbers here. So the first property is the associative property. And the additive form of this is if you're adding three numbers, A, B, and C, you can go by the order of operations and add A and B first, and then C. Or this property says you could choose to add B and C first, and then add A. For multiplication, same idea. If you're multiplying three numbers, order of operations say you would multiply the first two and then the third one. And this says you couldn't choose to multiply the second two than the first one. Notice in neither of these cases does it say you can combine A and C together and then combine B. This just says you can pair up the values, whether you're adding or multiplying, by who's next to each other. Now, if you want to add A and C, what you need is this next property, the commutative, which says that order doesn't matter when you're adding. So A plus B is the same as B plus A. So you can think of if you had A plus B plus C, you could switch the B and the C around and put A and C right next to each other. And that would be a way, or switch the A and the B around and put A and C next to each other. Now it would be a way you could add A and C together. Same thing with multiplying. A times B is the same as B times A. The identity property for the additive form of this says that if you have a number and you add 0 to it, you keep the same number. Now, sometimes we use this just like this, or sometimes we might add 3 and subtract 3 at the same time, and that's the same as adding 0. For multiplication, if you multiply by 1, then you get the same number. So you think identity means you don't change the value you're working with. And again, sometimes we use this idea of multiplying by 1. Other times we maybe will multiply, like if we're dealing with fractions, you might multiply top and bottom by 5. Well, 5 over 5 is 1. So that's why that method of, say, adding fractions, changing to equivalent fractions applies. It's because you're really just multiplying by 1. You're using this multiplicative identity. Inverse identity. If we add a number to its additive inverse, or its opposite, we will get 0. So there's always, for every real number, there's an additive inverse to it. For multiplication, if you take a number times its reciprocal, you'll get 1. That's the multiplicative inverse, or reciprocal. Now, this should be noted, this property, this multiplicative inverse, does not work for 0. 0 does not have a reciprocal because 1 over 0 would be undefined. So you think of, there's no number you can multiply 0 by to get 1, because 0 times anything would be 0. So, but all these other properties apply to all real numbers. This is the only one that has an exception, that it doesn't apply to 0. And then we have the distributive property. And it's not really addition, it's not really multiplication, it's a little bit of both. So what this says is if you're adding two numbers and then you're multiplying by a third, you could instead multiply each one individually, then add them together. There's also a version of this where maybe you're multiplying something on the right hand side, and then you're adding and then multiplying by that, so you can multiply each one individually and then add the answers. So that's called right hand distribution. For real numbers, it doesn't matter, because you can always think order doesn't matter. You could have moved that C up in the front, and then you can use the first version of it. But that is a property of it. Okay, so one of the things we need to realize, what are like terms? Terms are like terms are terms with the exact same variable part. So let's say we had this expression, 1 minus 2x plus 5x squared minus 6y plus 8x plus 14y plus 8 minus 11x squared. And we wanted to know, okay, who are the like terms? Which terms are alike? And so two like terms are positive 5x squared and negative 11x squared. Remember, the sign goes with the term. So if it's a negative, or if it's a minus, that just means the term is negative. You're always adding terms. Some other terms, negative 2x and positive 8x are like terms. Negative 6y and positive 14y, those are like terms. And then, we said they have to have the exact same variable part. Well, 1 and 8 don't have variables, so that matches. They have the exact same variable part, which is no variable part. So they're like terms. And one of the things we might be concerned about is what order do we want to write these expressions in while we're doing our work. And I've actually put these in the correct order, these pairs of like terms. The order is you go by highest power of the variable, work your way down to the lowest power. So you think about x squareds come before x's, or y's, and both of those come before 1 and 8, which don't have any variables. So they're the constant terms. Now notice about the x's and the y's. Both of those have a power of 1. How do I decide there? And you go by alphabetical order when they have the same power. So power is more important. If we would have had z to the third, that would be the first thing. And then x squared, and then x and y, and then the constants. But highest power, and then you go by alphabetical order if you have the same power. So adding and subtracting variable expressions, what we're going to do is combine like terms. What that means is you're going to put the like terms together and combine the coefficients. So again, I'm just going to take this expression and I'm going to rearrange the order of the terms. I'm going to put them, pair them up with their like terms. So 5x squared I'm going to put with negative 11x squared, negative 2x plus 8x, negative 6y plus 14y, 1 and 8. Now, why am I allowed to do that? Well, because of the commutative property. Commutative property says you can rearrange the order. And, if I can move 2 of them around, I can move all of them around. I just have to, if I wanted to do that, I would pair, move 2 around and then move a different 2, and then until I got them all in this order. Now I'm going to pair them up. I'm going to put the x squares together, I'm going to put the x's together, y's together, and the constants together. Why? Because of the associative property of addition, which says you can associate, you can group things however you want, as long as they're side by side. So I use the commutative property to put them side by side, then I use the associative property to pair them up. And then what I can do is I can get those x squareds out, so I'm only dealing with 5 and negative 11, get the x out, negative 2 and 8, get the y out, negative 6 and 14, and again 1 and 8. Now why is that? Well, this is actually the distributive property in reverse. You can think of this as that right-hand distribution. We said that if you're adding and then you're going to multiply, you can multiply each one individually instead and then add. Well, I'm just doing that in reverse, saying if I'm multiplying first and adding, I could actually add first and then multiply. And now I just figure out what 5 minus 11 is, negative 2 plus 8, negative 6 plus 14, and 1 plus 8. There is my expression. Now, I've shown here a lot more work than I would expect on this problem, but I wanted to give you a clear idea why we're allowed to do the things we're doing. Why is it when we combine the 5x squared and the negative 11x squared, that is negative 6 still x squared? Why doesn't the x squared change? Well, because we distributed the common x squared out, and we just combined the coefficient numbers, the 5 and the negative 11. So you don't change the x squared. It has to deal with the distributive property in reverse. So a problem like this, if I asked you to simplify 11 plus 3x minus 5x plus 17, I wouldn't expect to see all this work. I would just expect you to say 3x minus 5x is negative 2x, 11 plus 17 is 28, so this is negative 2x plus 28. That's as much work as you really need to see on that problem. So when should I show more work? Well, when you need to show more work. And I'm sorry I can't give a more clear answer than that, but you don't necessarily have to prove all these steps like I did here, though you could, but show enough work. Let's just put it that way. Alright, so what if we're multiplying or dividing variable expressions? Well, we're going to multiply the coefficients together and the variables together. So let's say we looked at this problem. I said, okay, well this problem's the same as negative 3 times x, 16 thirds times x squared, and times y. Now why is that? Because if things are touching, that means they're multiplying. So if negative 3 is touching x, that means you're multiplying negative 3 and x. I can drop the parentheses. Why? because all I'm doing here is multiplying. So according to the associative property, if all I'm doing is multiplying, I can group these up however I want or ungroup them as I did here. So I dropped the parentheses because all I'm doing is multiplying. Now I'm rearranging the order. I put the 16/3 together and I put the x with the other x squared. Why am I allowed to do that? Again, the commutative property. And maybe, whenever you take a whole number times a fraction or an integer times a fraction, you might want to write that as a fraction itself. So you can think -3 is the same as -3/1. And now what I'm going to do is I'm going to multiply that -3/1 times the 16/3, and I'm going to multiply the x times the x squared. And then whatever those answers are, I'm going to multiply by the y. Again, why? Because I can use the associative property, so I can group these up however I want. In this case, I'm grouping the constants together. I'm grouping the x terms together, x parts together, and there's only one y, so I'm just going to leave the y there. And again, remember, x squared is the same as x times x. So now I'm just going to multiply these together. The 3 and the other 3 cancel each other out. I get -16/1, which is -16. X times x times x is x to the third. So this is -16 x to the third y. And there's my answer. So you kind of look back in there. That's, again, a lot more work than you need to show. But if I look at the original problem, if you take -3 times 16/3, you're going to get -16. And if you take x times x squared, you're going to get x to the third and then times y. Since all we're doing is multiplying, just put everybody together. Now we get to this problem. Notice I'm multiplying. The 5 is touching the parenthesis, but I'm also subtracting or adding a -3. So how do I handle that? I use the distributive property. The distributive property says if you are adding or subtracting and then multiplying, you can multiply each one together first. Now, why couldn't I just put x and -3 together? Well, they're not like terms, so I couldn't combine them. So if I try to follow the order of operations, exclusively, I could not get past the first step. But luckily, I had the distributive property to kind of get me around that problem. So I can take 5 times x and 5 times -3, which gives me 5x and -15. 5x plus -15 is the same as 5x minus 15. We like to write things as simple and concise as possible. So please don't leave your answers as 5x plus -15. Write them as 5x minus 15. Let's say I was looking at this. Can I use the distributive? Well, first of all, let's look inside the parenthesis. X squared minus 4x plus 8. Again, no like terms there. I can't put those together. So if I try to follow the order of operations, do the inside group first, there's nothing I can do there. But I can multiply by using the distributive property. So I can take -6 times x squared. Can I use it for 3 terms? Sure I can. I can use it for 3, 4, 5, 6, however many. All I have to do is just take that -6 times the first term, take that -6 times the second term, and take that -6 times the third term. So -6 times x squared is -6x squared. -6 times -4x is positive 24x. -6 times 8, -48. You can see how those colors, where those came from. The -6x squared came from the -6 times the x squared. Alright, let's make it a little bit more complicated. What about this problem? So again, I'm trying to follow the order of operations as much as I can. I want to do my groups first, but x minus 3, no like terms. X plus 4, no like terms. So now what I want to do is, I don't have any exponents, I want to multiply if I can. So I'm going to take 8 times x and 8 times -3, and I'm going to get 8x minus 24. Then I'm going to take -2 times x and -2 times 4. Again, that's a -2. That just means we're adding a -2 there. So -2 times x, -2 times 4, -2x minus 8. Combine like terms. 8x minus 2x is 6x. -8 and -24 is -32. So you distribute and then you combine like terms. Again, we're trying to follow the order of operations. We're just using these properties of numbers to kind of get around situations that we can't work with because things don't match. Alright, so let's look at this interesting problem. 1 minus 7 times the quantity 3x minus the quantity 6 minus 2x. Now, order of operations say we should do groups first, and so you go to the bracket part, and again, you should do groups first inside there, and I would go to the parentheses, so you work your way inside out. And so I go 6 minus 2x, again, not like terms, I can't do anything, so I go to the bracket, and I'm going to distribute a -1. You see that negative sign in front of the parenthesis, you can think of that as a -1 times 6, a -1 times 2x. So this is 1 minus 7 bracket 3x, -1 times 6 is -6, -1 times 2x is a positive 2x. Notice I can't put 1 and 7 together. That's an addition, and if you think of order of operations, that's the last thing you should do. So I'm going to go inside the bracket. I'm still working on my group. 3x and 2x make 5x minus 6. So I can combine. I'm going to combine what I can inside my group here. And now I'm here. I can't do any more with the group. 5x and 6 are not like terms. So then next exponents, no exponents. So now I come to multiplication. Well, notice that -7 is touching the bracket, which means multiplication. So I'm going to distribute -7 times 5x, -7 times -6. It's going to give me a -35x plus 42. Now, at this step, I can finally work the 1 into the problem. So 1 plus 42, that gives me the 43. So don't try to get rid of that 1 minus 7 right off the bat. You think, oh, I can do that. That's -6. I'll get it done and out of the way. But order of operations say you have to wait till the 1 to deal with the 1 until you get down to the adding and subtracting. Since that 1 wasn't multiplying anything, it has to wait till the very end. It's not about looking for the easiest thing to do. It's the correct thing to do.